Hi, my name is Jani Marjanen. I work in the NewsApp project in the Helsinki Computational History Group. In this video, I'm going to talk about optical character recognition, or OCR. OCR is the process of converting old printed or handwritten texts into digital form. It is what allows us to computationally manipulate historical records in the same way we work with modern digital-born materials. OCR is most often done by libraries, museums, or private companies, but you can also do OCR yourself with programs like Transcribus or by doing conversions in Google Drive. Sometimes you will encounter HTR, handwritten text recognition, or ATR, automatic text recognition. They are based on slightly different methods, but are also about converting text into digital form. Without OCR, the field of digital humanities would look very different. So, OCR is fantastic, but there are some issues you need to know about. For instance, OCR is not perfect. It will introduce characters that weren't in the original, it will omit things that were there, or read something wrong. Say that you wanted to find instances in which the word nationalism is used in 19th century Austrian newspapers. You enter the word and do a search. It will give you plenty of interesting hits, but at closer inspection, you see the early hits are not for nationalism, but rationalism. The OCR engine has confused capital R and capital N. This is called a false positive, and it means that the precision of your search is not perfect. Errors occur also the other way around. In those cases, what you're looking for exists in the data, but you can't find them because of faulty OCR. This is called a false negative and means that the recall of your search is not perfect. Whether your problem is in precision or recall, you can work around them by using fuzzy searches or regular expressions to modify your search. A bigger issue than individual errors is that failed conversions are unevenly spread in the data. This is a problem especially when you're not trying to search for things, but also want to quantify your results, or use some kind of algorithmic method. Most methods can handle some OCR noise, but some challenges, such as grammatical parsing, are more prone to fail if there are plenty of errors. How many errors can be tolerated depends on the methods you use and what you use them for. Uneven spread of errors occurs because some pages or letters are more difficult for the OCR engine to read. For instance, in 18th century British texts, you'll often see the long S, which is very hard for the engine to decipher. In newspaper data, advertisements are more likely to contain errors than regular articles. So whatever data you use, you should know if and when there are such typical OCR errors in it, because they will affect your results. Still, creating digital text has become increasingly reliable. For printed text, the character error rate, CER, is nowadays very small, often under 1% of the characters. Even for handwritten texts, projects have reported correct conversions of more than 95% of the characters. So if OCR text often looks like this, in a few years it's more likely to look like this. To conclude, if you know your method and you know your data, you can do fantastic things with OCR datasets.